In this chapter, we're going to look at three different types of discrete probability distributions. The first one is called weighted average. Each of the three has an important place outside of the classroom, so it's a good idea for you to understand how each works. The weighted average, an example of which is listed below, is where a New York specialty shop sells expensive designer handbags that sell for $2,500 or more. They have decided to track the sales for these bags in order to decide how many they need to carry in their inventory. They'd also like to use the statistics that they've accumulated to design a commission system to compensate their salespeople. They've tracked the sales on these bags for the past year and accumulated the results and listed them in the table that's shown below. In order for us to use this data, we're going to start out by totaling the number of days column. We need to do that as a way of understanding how many days data the table represents. So highlighting the row underneath the number of days column, we're going to use the auto sum feature in Excel, and when we hit enter, it's going to give us a total of the number of days data that we are looking at on this. We're going to title that column the function of x. We could have used probability of x because that's what it is. When we divide the 21 days of no sales by the total, which is what we're going to do now, we are going to get the relative frequency that 0 sales is against the total. So we're going to divide by the total, and before we leave that, we're going to freeze the 360 so that we can copy the formula down and use the 360 to calculate each one of the rows. Once we have that number, we're going to highlight that. We're going to grab hold of the little button on the side and drag it down so that it goes to all of the fields. And now we're going to get a probability for each one of the sales that are made on any given day. We're going to total that column also to make sure that we've done our calculations correctly, because if we have, that column will total to 1.0, and it does. Now we're going to take and calculate expected sales. And the way we're going to do that is we're going to use the probability that we've just calculated times the daily sales. So our first one would equal 0 sales times the probability for 0, which would obviously give us 0. We are now going to copy that down to all of the rest of the rows, and it's going to give us these numbers. We're going to change this column so that we're looking at 4 decimal places, and that's just a matter of personal preference. Once we have that, we're going to total this column, and when we total this column, what it's going to give us is the sales that we could expect for the handbags on a daily basis. In this case, about 2.6%. The percent would be 2.6 actually handbags on any given day. The next step would be to subtract the expected sales from each one of the daily sales, starting with 0. So we're going to say that it's going to be 0 minus our 2.5722, and we're going to make that column frozen so we can also carry that down to all of the rest of the rows. I'm going to highlight the 2.572, and then we're going to drag that down to the rest of the rows. Once we have that, by formula, we're going to raise the number in column F to the second power, and we're going to use the Excel function power. We're going to highlight not G16, but F, and we're going to put in a comma and 2 to raise that to the second power or square it. Once we have that number, we're going to be able to drag it down to all of the rest of the rows. And once we have that, the last step would be to multiply each one of these numbers by the probability number, which is shown in the f of x column. So this is going to equal this times this. Once again, we're going to roll that down to all of the rest of the rows rather than re-enter the formula each time. The sum of this column, which we'll get again using the auto sum, is going to be the variance that we can expect in the data. So what is that telling us? We got 2.6 is the expected sales on a day that could vary by almost another 2 units. We could show this in a smaller number of decimal places, but what we're really looking to get at is the standard deviation of the data, and that equals the square root. As you see, I'm keying in square root. I'm highlighting the variance field, and when I hit enter, I'm now going to show that I have an error here. When I take the square root of that, it's going to come out as 1.327, which is the standard deviation of the data. So I have an expected sales of about 2.6 that can vary plus or minus 1.3. Not a necessity, but just as a matter of personal preference, I'm going to highlight the variance and standard deviation, and I'm going to use the feature up here where my arrow is going to change the decimal places so that what I'm looking at is consistent with what I've got in expected sales. I'm showing this to 3 decimal places, and then you see expected sales is 4, so kicking one the other way. Now all 3 of those numbers are expressed in the same number of decimal places. And I'm going to be able to use that number to understand that on a daily basis I need 2.6 of the bags in stock in order to meet the potential demand. And if I want to be extra sure, I would use the standard deviation to build in a little safety stock so that I would always be in a position to satisfy customers when they came in.